Today we're going to be writing equations of parallel and perpendicular lines. So before we start, I want you to draw a straight line cutting this box in half because we're going to separate and talk about parallel and perpendicular lines. All right, the first thing we're going to discuss is parallel lines. And we have already talked about parallel lines a lot this year, but parallel lines are two lines that never touch. So if you draw it over here, they look like a railroad track because they will never intersect. Okay? And I've already taught you about their slopes. Who can tell me about parallel line slopes? They are the same. So their slopes are the same. So same slope, but different y-intercepts. So we're going back to y equals mx plus b today. Now, could you write these in standard form or point slope form? Absolutely. But it's just easiest to deal with parallel and perpendicular lines in y equals mx plus b form. Okay, and if you'll extend this line out, I'm going to give you two examples of parallel lines, or an example of one set. So if I have y equals 3x plus 4 and y equals 3x plus 6, why would those be parallel lines? Because they have the same slope and different y-intercepts. Okay, so let's highlight the important stuff. They have the same slope. So I want you to highlight that their slopes are both 3. But they have different y-intercepts. Okay, so y'all should have that down because we've talked about it so much this year. On the other hand, perpendicular lines are lines that meet and make a perfect T. They make perfect 90-degree angles. So if you draw like this, and they make this perfect right angle, those are perpendicular lines. Now, they don't have to stop, like they obviously keep going forever, but perpendicular lines meet at a perfect intersection of 90 degrees. Okay? These lines will have slopes that are opposite reciprocals. Okay? So the slopes, and I'm going to write it up here because we're not going to have enough room. Actually, we should have plenty of room. So let's just write the slopes are opposite reciprocals. That's reciprocals. The slopes are opposite reciprocals. That's a RE. And I will give y'all examples of those. So highlight what their slopes are. Slopes, opposite reciprocals. And I know y'all have heard the word opposite, and I know you've heard the word reciprocal. Yes? Okay, so let's talk about it. If I have an equation, y equals 3x plus 4, just like I had up here. To be parallel, then the slope would have to be 3. But to be perpendicular, you take the slope, you make it opposite. Meaning, what's the opposite of positive? So it's going to be a negative, so y equals negative. Then it's a reciprocal. What's a reciprocal? Where you take a number and you do what? You flip it. So this is 3. If I have a numerator over denominator, isn't that 3 over 1? So if I flip it, what is it? 1 over 3. And it honestly does not matter at all what the y-intercept is. It can have the same y-intercept. It most likely won't, but it doesn't matter. It can be anything it is as long as the slopes are opposite reciprocals it's going to be perpendicular. So you could put whatever you want, plus 2, I don't care. Again, all we care is that the slopes are opposite reciprocals. All right, so I'm going to say it again. If they're parallel, their slopes are the same. Now, why would their y-intercepts have to be different? Because if their slopes are the same and their y-intercepts are the same, they're not parallel, they're the same line. That's why. Okay? Perpendicular, their slopes have to be opposite reciprocals. So honestly, guys, this is a super easy lesson. It's just for some reason, students have a hard time with that opposite reciprocal piece, and I'm not really sure why. Because y'all been doing reciprocal since 6th grade. Okay? All right. What we're going to be doing is we're going to be writing an equation of a parallel line that passes through the given point and is parallel to the given line using the slope-intercept form. All right, so what did they give you? They gave you the equation. Are y'all with me? So if I graphed this line and it said another line passes through this point and is parallel to this line. So do y'all understand what it's saying? I'm going to say it again. If I graphed this equation, it's a straight line. It's going to pass through -1 on the y-axis. It's going to have a rise over run of 3 over 1. Are y'all with me? And I wanted to graph a parallel line to this, but the line that I'm going to graph is going to pass through this point. Are y'all good? It wants me to write an equation of that line that's parallel to this, but passes through this point. Okay? So to do this, you already know the slope. Because to be parallel, what do we know? They have to have the same slope. So to be parallel, they're going to have the same slope, but I'm going to have to solve for the B of the new line. Because I already have the M, I'll just have to solve for the B. So y'all already know how to do all of this. Excuse me. All right, so let's go do it. What is the slope of the line that's parallel? 3. The M is 3. How do I know that? Because they share the same slope. They will not share the same y-intercept. So I'm going to have to solve for the B. Are we okay? All right, so to solve for the B, can I plug this in for X, this in for Y, and 3 in for M? Yes, so I'm going to do Y equals MX plus B. This is my X, this is my Y, and 3 is my M. So I'm going to write -5 equals 3 times -3 plus B. All right, -5 equals 3 times -3 is -9 plus B. How do I get rid of the -9? Plus 9. And I have B equals, and -5 plus 9 is 4. So my B is 4. Can I now write an equation that's parallel to this line but passes through that point? Yes. What's my equation going to be? Y equals, say it. Perfect. Y equals 3x plus 4. And then check yourself. Are these two lines parallel? Yes, their slopes are the same, but they have different y-intercepts. Now, why did they give you a specific point? Because if they didn't, you would just make up your own equation and say y equals 3x plus whatever number you want it to be. And that's true. It is parallel. But they want it specifically to pass through that point. Okay? All right, let's try another one. So here is our equation. If I graph that, they want me to write an equation that's parallel to it, but passes through this point. So the slope has to be what? -1. I have to solve for the B because they don't give it to me. Are y'all good? All right, this is going to be my X. This is going to be my Y. So I have 11 equals negative 1 times negative 2 plus b. Are we all writing? So I have 11 equals negative 1 times negative 2 is positive 2 plus b. How do I get rid of the positive 2? So what is 11 minus 2? 9 equals b. And I can now write my equation in slope-intercept form of the parallel line that crosses through this point. So y equals negative 1x plus 9. Did I have to write the negative 1? Or could I have just written negative x? Same thing, right? All right, let's do one more. They want us to write an equation of a parallel line to this equation, but that passes through this point. So what will the slope have to be? Negative 2. So I'm going to have an m of negative 2. My job is to solve for the b. Okay, so I have y equals mx plus b, where I'm going to plug in 3 for y, negative 2 for m, and negative 3 for x. So I have 3 equals, and negative 2 times negative 3 is positive 6 plus b. If I subtract 6 from both sides, what is 3 minus 6? So I have negative 3 equals b. I now have an m and a b of a parallel line that I can write an equation for. So my equation is going to be y equals negative 2x minus 3. All right, do y'all have any questions on how to write parallel lines? Are we good? Okay, I want to skip this section. We're going to come back to it. And we're going to go to the back and do our perpendicular lines. All right, what did we learn about perpendicular lines? Their slopes, so write this down. Slopes are opposite reciprocals. So we're going to do the exact same thing we just did, but instead of the slope being identical, we're going to have to make it the opposite and flip it. All right, y'all ready? They want us to write an equation that's perpendicular to this line, but passes through this point. So I need to take the slope, and I need to identify its opposite reciprocal. So because it's positive, the perpendicular slope will be negative. And I'm going to take 2. What is 2 over 1? And I'm going to flip it, and it's going to become 1/2. Are y'all good with how I got the opposite reciprocal? And now I'm just going to solve for b like I've been doing. So there's nothing new. They're the exact same thing, except parallel, the slopes are perfectly identical. Perpendicular, they're opposite reciprocal. All right, so here we go. I'm going to write y equals mx plus b. I'm going to plug 5 in for y. I'm going to plug in negative 1/2 for m. The x is 4, and then plus b. Okay, so I have 5 equals. A negative times a positive is a negative, and what's half of 4? 2. How do I get rid of the negative 2? Plus 2. So 5 plus 2 is 7. So 7 equals b. I now have my m and my b, so I can now write an equation in slope-intercept form that is perpendicular to this line. So y equals negative 1/2 x plus 7. What do y'all think? It's really not hard, right? The biggest thing is just students remembering the slopes. Like, are they the same or are they opposite reciprocal? All right, I want y'all to try this one on your own. Identify the slope and then solve for the b. Okay, check your work with mine and see how you did. What do y'all think? Did y'all do okay? Yes? All right, let's just do one more together. First, we have to identify the slope. But look at this equation. Is it in slope-intercept form? It is not. So to make it in slope-intercept form, I need to move the 3 to the other side by subtracting. And it's y equals 2x minus 3. So you always have to have it in slope-intercept form just so you can identify the correct slope, yes? So the slope is 2. I am writing an equation of a perpendicular line, so the slope is going to be opposite reciprocal. So instead of positive, it's going to be negative. Instead of 2, I'm going to flip it, and it's going to be 1/2. All right, so I'm going to write y equals mx plus b. I'm going to plug in 2 for y, negative 1/2 for m, negative 5 for x, and I'm looking for the b. So I have 2 equals, and negative times a negative is a positive, and I can multiply straight across and get 5/2, or you could put 2.5, same thing, plus b. Y'all know 5/2 is 2.5, right? Then I subtract 2.5 or 5/2. And 2 minus 2.5 is negative 0.5, or negative 1/2. So the b is negative 1/2. So my equation ends up y equals negative 1/2 x minus 1/2. Okay, flip back to the front. Now we're going to look at equations that they gave us. So they're going to say, determine which lines, if any, are parallel or perpendicular. So they gave you an equation on A, B, and C. How do I know if they're parallel or perpendiculars? I have to look at their slope. So what is the slope of A? 5. Can I see the slope of B the way it is written? Is it in y equals mx plus b form? So what do I need to do first? Rearrange it so I can see the slope. So I would need to move the x by subtraction. So I have 5y equals negative 1x plus 2. Why did I put a 1 in front of it? Because it's going to help me see the slope, yes? I'm going to divide everything by 5. And right there, I can see the slope of this line. What is this slope? M equals negative 1/5. All right, let's do C. Is C in the proper form to see the slope? No. If you say the slope is -2, you are very wrong because it's not in slope-intercept form. I need to get rid of that coefficient to that y by dividing. So I have y equals -2 over -10 simplifies to what? 1/5 x, and then 0 divided by -10 is 0. So I have a slope of 5, of -1/5, and of 1/5. Are any of them parallel? They have the same slopes, yes or no? No. So none of them are parallel. Are any of them perpendicular because their slopes are opposite reciprocals? No. Which ones? A is perpendicular to B. You do not have to spell out perpendicular. The way that you're going to write this is you're going to say A is perpendicular to B because this is the sign for perpendicular. And that's your answer. All right, let's do one more. Again, I'm going to see which ones are parallel or perpendicular for these three equations. Before I can do that, the first thing I have to identify is their slope. All right, so I'm going to move the 2x to the right by subtraction. So I have 6y equals -2x minus 3. How do I get rid of the coefficient 6? Divide everything by 6. And then simplify. So I have y equals, if I divide the top and bottom by 2, it becomes -1/3 x minus, and I really don't care about the b, but I'll go ahead and write it. If I divide the top and bottom by 3, it becomes 1/2. So the slope of this one is -1/3. Do I need to rearrange this one, or is it already done? All right, what is the slope? 3. Do you already see something? What are those two? They're perpendicular. All right, but we got to go do this one because it might be something to these two, okay? So I got to go rearrange. So I'm going to move the 4.5x to the right by subtraction. So I have -1.5y equals -4.5x plus 6. I'm going to divide everything by -1.5. And I'm going to get my calculator to do this. The slope is 3. Do y'all see that? The m is 3. Where did I get that? I simplified this right here. All right. Are any of these parallel? Which ones? B and C. How would I write that? I would write B is parallel to C. Is that my only answer? No. What else do I know? A is perpendicular to B. What else? And C. So I would say A is also perpendicular to C. I have 3 answers on that. All right, last question on the very back. They give you a graph that is horribly hard to read, but it basically says a hockey puck leaves the blade of a hockey stick, bounces off a wall, and travels to a new direction. Write an equation that models the path of the puck from the blade of the hockey stick to the wall. So from here to here, they want an equation. Well, really, I don't even really need an equation. I just need the slope, but we're going to write an equation, and I know y'all can't see those coordinates good. This is -4, 0. This is 0, 8. And this point up here is -4, 16. All right, so we're writing an equation of these two. Do I already see the y-intercept? What is it? 8. All right, so I just need an m. Can I use slope formula or stat? I want to use stat. Okay, so I go to stat edit. So I have 0 and -4. 8 and 0. Stat calc, option 4. What's the slope? 2. What's the y-intercept? So the slope is 2. The y-intercept is 8. My equation is y equals 2x plus 8. That's all it asked for, right? Write an equation of that path. The second one says write an equation of the path of the puck after it bounces off the wall. So here's it bouncing off the wall. So can I just use these two coordinates? Okay, so stat again. -4, 0, 16, and 8. Stat calc. There's my equation. Y equals -2x plus 8. The question says, does the path of the puck form a right angle? How would I know? If it's a right angle, it makes a perpendicular line. How do I know that? Because perpendicular means it makes a right angle. So are these slopes opposite reciprocals? No. So the answer is no, it does not, because the slopes aren't opposite reciprocals. I'm just going to abbreviate. Okay, put your name on your paper. On 1 through 3, it says identify the slope of a line that would be parallel to the given line. So the first thing you're going to have to do is rearrange them to find the slope. Now, on number 3, do you even need to rearrange it, or do you see the slope because it's in point slope form? You'll see it? But on number 2, you can't see the slope from standard form. You would have to rearrange number 2. Make sense? All right, number 4 through 6 says identify the slope of a line that would be perpendicular. So you're going to have to see the slope. Well, number 4, you can see it because it's in slope-intercept form. Number 6, you can see it because it's in point-slope form. But number 5, can you see the slope? No, because it's in standard form. So you're going to have to rearrange it first. Then you're going to write the perpendicular slope, meaning opposite reciprocal. Okay? All right, number 7 through 12 says write an equation of the line that passes through the given point and is parallel. So same slope. So you're going to have to solve for the B, okay? On 13 through 18, it wants you to write an equation of the line that passes through the given point and is perpendicular. That's opposite reciprocal slopes. So you're going to have to find the slope, make it opposite reciprocal, and solve for the B. 19 and 20 are just like what we did where you're going to determine which ones are parallel or perpendicular. So A is parallel to B or A is perpendicular to C. I'm going to tell you, one of them only has one answer, one of them has 3 answers. Make sure you write all 3. And then number 21 is exactly like the question we did at the end where it says, is it perpendicular? So you've got to see what their slopes are. You can just do rise over run because they're hard to see. You don't even need an equation. You don't even need, it wants you to write an equation. Their y-intercepts are both 0. So right here, that's 0, 0. And then you're just going to rise over run to that point. Can y'all see it? And then this point right here for this line. Okay? All right, that's all. You may start.